Finally, particulate matter, or PM. PM is just what it sounds like. Tiny particles that fall so slowly they can hang around the atmosphere for a long time before being deposited on the ground. The particles most dangerous to human health have sizes less than a few microns. The most common measure of PM concentration in air is PM 2.5, the total mass of particles less than 2.5 microns per volume of air. PM can range from unburned nanoparticles of carbon emitted by diesel engines to tiny droplets of sulfuric acid formed from SOx emissions. PM is therefore both a primary and a secondary air pollutant. Some particles are emitted directly into the atmosphere, while other particles are formed in the atmosphere. PM is a major threat to human health. Scientists' understanding of the risks of PM and of other air pollutants is mostly based on epidemiological studies. Because estimates of health risks are so important in driving decisions about our energy future, it's worth taking a few minutes to look at these epidemiological studies so that you can form your own opinions about what they can and cannot tell us. Perhaps the simplest signs that particulate matter can harm our health are the correlations between measured PM levels and hospital admissions or mortality. This data shows the impact of very high levels of PM, but it doesn't show the impact of chronic, low-level exposure to PM. To figure that out, we can look at long-term health of people living in areas with different amounts of PM pollution. For example, different cities. Of course, the problem is that cities differ in all sorts of ways that can affect health: other pollutants, employment, average age, etc. Epidemiologists do their best to separate out each of these factors and estimate the impact due to changes in PM alone. Here are results from one of the most influential air pollution epidemiological studies ever done. The net result is that an increase in PM 2.5 of 10 micrograms per cubic meter decreases your lifespan by roughly 3/4 of a year. The annual average PM 2.5 values in Beijing approach 100. That means that residents' lives will be shortened by many years. Look up the PM levels in the city you live in and figure out how much it is likely to shorten your life. How certain are these mortality estimates? My view is that the overall estimates are pretty accurate, though they still might easily have uncertainties of a factor of 2 or even more. However, it is much less clear which component of PM causes the problem. Some researchers think it's mostly due to metals and toxins, while others think that most of the damage is simply caused by the total amount of PM, which mostly comes from sulfates and nitrates. The answer really matters, as it should shape where people put their efforts into pollution control. Here is the recent history of PM levels in the United States. Average PM 2.5 has fallen by about 1/3 since the year 2000. Now have a look at the time history of all 6 of the US criteria pollutants. Notice that progress for ozone and PM, the things that actually have the most health impact, have been noticeably smaller than progress for the individual primary pollutants like lead or sulfur. I do not think this is chance. It's easier to control single pollutants than it is to control PM and ozone, where many different sources, both natural and human, contribute in complicated ways to the total pollution load. How have these reductions in pollution been achieved? In almost all cases, they've been achieved by technological changes in the way energy is produced or used, either by changing the process to reduce the production of the pollutant, as when lead is removed from gasoline, or by adding cleanup technologies like sulfur scrubbers on power plants or catalytic converters on cars that remove the pollutants before they are released to the atmosphere. Beginning in California in the late 1950s, the United States began the modern era of air pollution control. The United States Clean Air Act is, arguably, the single most important example of air pollution regulation worldwide. The cost of control was not cheap. At the peak of implementation, the cost of the Clean Air Act approached 1% of the US economy. These costs exceeded the cost of all other environmental cleanup measures. What about the benefits? The benefits were huge. Several retrospective studies suggest that the monetary benefits of the Clean Air Act, lower healthcare costs, longer productive lives, were many times larger than the cost of implementation. By the time it has been completely implemented, the Clean Air Act will probably extend the life of an average US citizen by roughly a year. That's the level of impact we're talking about for environmental controls, an improvement in economy and lifespan and quality of life for everyone.